right? We're loading data into Snowflake with Python. And really, this is more like interactivity with Snowflake using Python and just taking a programmatic view of things. And well, we came up with something interesting just for the meetup since they're virtual. We want to have a little bit of virtual rules, a little virtual rule setting here, just for everybody to kind of stay safe and sane. And really, we're just asking everyone to be respectful of all the other participants. If you jump in here, try to keep yourself on mute. We're not regulating that hardcore right now. We try to keep it a really collaborative, social sort of session. So just make sure you're on mute and respecting everybody else. And then, of course, if you have a question, definitely go ahead and throw it in the chat. We've got some folks from the Carolinas Snowflake team here who are monitoring the chat. So if anything comes up, we'll make sure that conversations get started and questions get answered, all those types of things. And during the session, we're kind of like, well, let's ask questions that are relevant to what we're discussing. And then we've got really some open discussion at the end where we can jump into anything, any topic anybody wants to talk about. And turning your video on is completely optional. And we highly recommend you guys invite a colleague or a friend. Join us on one of the next meetups. We think we're having fun, and everything's going to eventually coalesce to having these in the real live at a restaurant or at a pub or some other outing. And so we're really trying to create a really good community here in the Carolinas, maybe even in the whole country, but focusing in the Carolinas for now around Snowflake and working with data in general. And then lastly, try to be social. So you can ping us at Data Lakehouse on Twitter as well as LinkedIn. And then my Twitter, my LinkedIn is somewhere in the slide deck. You guys can always ping me. We've got Heather Pearson, and we've got Superdeep Apasani from the team as well on the line. So really, any questions about Snowflake or working with it, I'm sure we can answer for you. So just a super quick refresher. I know everybody knows this, but every now and then we get people who are new to the meetup. So just kind of just doing a quick review. So what is Snowflake? Well, it's kind of they've created themselves as the data cloud. They started off as the cloud data warehouse, and really they're a great solution in the cloud using that elastic capability of cloud computing for ingesting data at all different levels of almost infinite scale, accessing data at almost infinite scale, providing that governance layer, and really that full data layer, especially when it comes to data warehousing or building data vaults or doing ELT, and that's for structured and unstructured data. And so it's a great platform. We're big fans, and ultimately a lot of organizations have problems that they need to solve around, hey, we have a lot of data from many disparate data sources. We're looking to get efficiency across the board, from ingress to egress. We need to do some transformations. We need it to be fast, and we have consumers of all different walks of life, and we need that all to be handled in a single platform. So for the most part, Snowflake is that platform, and there's a lot of things on the ancillary to that, or on the periphery rather, and we tend to highlight those as much as possible in these meetups, as well as dive into a lot of the inner workings of Snowflake where we can. So with that being said, just talking about Python. So again, Python being one of the more popular programming languages these days, but as we find, and maybe you guys find, not everybody is a programmer that works with data, and they might be an Excel master, but they might not be a programmer. For example, just stepping back a bit, what is Python? Well, without going into super lengthy technical detail, really Python's a programming language, right? It's just like, I won't say just like, but it's similar to some of the other ones that are out there, or maybe you've heard of, or maybe you took computer science studies back at university, or just by being in technology or around technology, you're aware of other languages like PHP, C++, C#, VB.NET, Java, in theory, JavaScript also could fall in that bucket these days for a lot of the front end stuff as well. But also Snowflake uses JavaScript for for developing their stored procedures, if you didn't know that. And so why do people like Python? Well, it's easy to use, and it's got some good similar programming structures. Like if you're coming from VB script or anything like that, or any other programming languages like JavaScript or Java, like it kind of flows in a very similar fashion. Obviously constructs and things like that are a little different, which makes Python unique. in theory, it's a declarative language. And then one of the things that people like about Python, especially these days with the data scientist, or people who like to call themselves data scientists, or just this term of data engineers, is that there was introduced something called notebooks, and Jupyter notebooks. There's a few other flavors out there. Jupyter seems to be the most popular, and it's really accelerated the use of Python over the years. As you can kind of see in this chart, I should have done a nice kind of map point there when Jupyter notebooks and Anaconda and all these things kind of came out. Did that really accelerate Python or not? That's something to look into. But really, it's a great platform to ease the development of writing Python code, connecting to data sources, doing machine learning, saving that kind of whole block of waterfall code off, and then reusing it, repurposing it, and automating it. And Python has lots of different libraries, just like many of the other popular languages. So you can kind of, bring in one of the libraries you need to use. And a lot of these are really amazing. Most of them, if not all of them, are open source. So it's really easy language to get in there and learn stuff. And then, of course, there's all this cool stuff, like you can use Python to do like web scraping, and all the way to like deep fakes detection, and a lot of great stuff. And so, as you can see in the chart, it's really accelerated. I mean, this comes from Stack Overflow, this chart does. And if you're familiar with Stack Overflow, I think I'm in there like once or twice a day, checking on errors and issues and bugs. It's a great platform, and they're going to have a lot of the data that's going to be able to measure, how many searches are done for Python per day and things like that. So it's a fairly credible resource looking at something like that. And then, of course, if you're sitting around a campfire and you're talking about, hey, how are people using Python today? Well, I think it's being used, I won't say ubiquitously, but it's pretty close. I mean, we see it in universities. We've talked to a lot of university hires over the years. Website development, you can build an entire web app, and there's several that are out there that are doing well. I don't know if they're unicorns or not, but you can build an entire front end and back end of your website basically with Python and JavaScript for the most part, HTML, CSS. And then, of course, you can even build pure command line interfaces off of Python. So, and I mentioned automation and scheduling tools earlier. So really, when you think about where can Python be used, all over the place, just like some of the other perhaps even more well-known languages. And then, like I said earlier, by all the data nerds that are out there, right? Data scientists, machine learners, or machine learning practitioners, analytics engineers, and so forth. Data analysts. We even have a client where the CFO knows Python and is doing data wrangling and data analysis with Python. So it's pretty straightforward, pretty easy to use once you grasp it, and you can do some really cool things. And then just kind of lastly, I think just kind of highlighting Python kind of by the numbers, again, kind of showed this one, but it's had a lot of growth in comparison to some of the other languages that might be either stagnant or decreasing in popularity, as you see PHP there on the downtrend. And then on the left, I mean, if you compare it to some of the other smaller technologies that are out there, like Rust or Scala or Swift, which I think is the Apple program language, if we're correct, or even R, which is, again, kind of a data sciencey statistician language. I mean, Python is just really, in a situation where it's taken off. So let me just bring this up into presenter mode here. So let's get into Python and Snowflake. But before we get started, I mean, any questions? I know we've got some folks out there that know a little bit about Python. Maybe it's a good point to break, because once we get into the code, we'll start just getting pretty technical. So I don't know if anybody has any questions. That might have been a pretty fast intro to Python and Snowflake, but no?
I have a question. What would you say is the easiest programming language to learn?
That's a head scratcher right there. Honestly, if I think about it, if I think about a programming language that would be the most useful, like across the board, from building a website, at least let's call it the back end of a website, like Flask, which could technically do some of the front end stuff too, but and then being it very useful. Like I could call it to run simple stuff like people do on their own machines. Like I want to, run a script that changes all the file name, the extension of all file names from like, XLS to XLSX, or like just kind of these very functional things that might be on my machine, or even like, pull in a spreadsheet and do some math on it. I'm a big fan of Java myself, which also means almost by nature, I'm a big fan of Scala and, like Spark and everything. But I'm going to have to say that, I've been using Python, and actually there's a version of Python called Jython. It's a Java-based version with kind of like the same standards and declarations and things. So I've been using a combination of those two for, I think, about 10 years, if I'm calculating that correctly. And I've been using Java for, I don't know, 15 years anymore, and then all the .NETs since they came out. So I'm gonna have to say Python with that long-winded explanation. I'm gonna say Python is at this point, I think it's the easiest one to use, if that was the question. And I think it's the one that can provide the most like benefit across like so many different areas of use cases. Yeah. Like I said, if you want to scrape a website and pull some, if you want to log into a website remotely, connect to it, go to a page, pull the data out, do something with that, that metadata from a page, like Python. I mean, you can do it in like less than maybe 200 lines of code. So I think I'm gonna, yeah, let's go with Python. Very apropos for today's session, I think. All right, so if everyone can see the slide here and the screen, okay, then I will carry on. As a matter of fact, let me switch something really quickly. Let me just pause this here. So I'm gonna go into kind of stop mode here, and then I'm gonna present just that slide and I'll have to jump off of it in a minute. So let's do just that slide. Because I think this is what I'm missing. All right, hopefully that's better, a little bit more full screen. And I'm gonna have to jump right out of it to do the kind of the real-time analysis here. So what do we want to talk about here? So in this meetup, and again, we'll keep it as interactive as we can. So what do we want to talk about when we're talking about Python, Snowflake? Well, first of all, Python doesn't equal Snowflake. I actually had that question earlier before we started doing this session. And someone said, well, is Snowflake built on Python? What's the difference? Why would you even use it? So I think I gave a little bit of reason why you might use Python and connect to Snowflake, but Snowflake is its own standalone platform as a service or software as a service entity. You sign into it through, on your desktop, or I don't know if you can do mobile, and you log with username and password or some other authorization mechanism, and you're able to, let's just call it, work with your data. Okay, there's a user interface. And then Snowflake provides SDKs and APIs, just to keep it simple, so that you can then connect through a client tool or client programming language like Python or Java. And then you can do something with the data that you have or metadata that you're working with or have stored in Snowflake in your account of Snowflake. So you would get your account credentials, and you would take those account credentials and you would use your programming language. In this case, we'll use Python. And then you'll connect to Snowflake as, let's just be called, simply a repository. And then from that repository, you can then use that data as you're connected with your programming language, and then use all the accoutrements of your programming language to then do things. Like, so if you're like a pandas data frames guru, you could bring some of that data down from Snowflake into your local Python environment using data frames, and do all the things that data frames does, right, with that data. And then obviously you can iterate through the data, you can bring it down in a batch, you can now do all sorts of things, right? So what we're going to go through today is just going to look at, saying, hey, Python's a nice approach to do that. And you could even do it on your laptop. Now, obviously there's levels of scale, so you could use like elastic computing and like a Google Cloud Platform or Azure or AWS, and you could get a virtual machine, or you could use like Lambda functions to connect to Snowflake and work your magic there. We'll look at a couple ways you can connect. We'll probably just stick with one in the session today, but if anybody has a question, we can probably answer that. And then we'll just execute commands. So, I'll be working remotely from my laptop in kind of like live demo mode, connecting to our group's Snowflake instance and working with some data there. And then we'll try to push some data and test some data and stuff like that. So break it down simply. We'll get our account, we'll connect to it, we'll create some stuff, we'll check some stuff, and we'll load some stuff. Keep it simple. I did mention Jupyter Hub and Jupyter Notebook. A lot of people don't know this, and I found this the other day working with a really cool customer of ours. And the team of data scientists actually had been working all on their laptops, and everybody has a Jupyter Notebook on their laptops. And actually, there's something called Jupyter Lab now, which is kind of the predecessor of Jupyter Notebooks, but it's the same concept. And so there's something called Jupyter Hub, and Jupyter Hub is like a centralized Jupyter Notebook platform. It's really like for collaboration. So you can deploy Jupyter Hub into a server, and that server could be on the cloud or on premise. And then it basically acts as a web app where you can set up multiple users, and then each one of those users gets their own kind of like notebook server. So you could, in theory, do all the stuff you're doing on your laptop if you're using Jupyter Notebook or Jupyter Lab, but you can do it centralized as a company. We use it, at AICG and for Data Lakehouse, and like I said, it's pretty cool. It's pretty straightforward to set up and just allows everything to be centralized. And you can still work from your local laptop on your own instance, and then you can just save off your IPYNB files, and then you can push those up to the server, and then you can share access to them that way. You could obviously use GitHub or whatever your Git source control management is for that, but just another way to look at it. And then I guess before I jump into it, the other question we had was around, if we do connect from our laptop or from our server on Amazon Web Services or Google Cloud Platform, how can we protect our Snowflake instance? So you might not be the administrator of your Snowflake instance for your account, for your company, or for your team or whatnot, but the administrator should know this, that you can set up a network policy. And the network policy will allow you to restrict, or what they call whitelist, IP addresses, so that only certain machines, computers, people calling from certain IP addresses can actually connect to your Snowflake instance. And that's super important, obviously, especially with all the hacking that's going on in the world and people just pinging servers to see if they can get access and, use dictionary attacks on passwords and such. It's only a matter of time before somebody, can break into someone else's systems. And Snowflake does a great job, and it's a platform as a service. But just in case you want extra layers of protection and security, network policy is awesome. So again, most people aren't admins of their systems. So if you're not sure your admin's done that, now you can bring something to them and let them know stuff about the Snowflake. All right, so let's go and get started into the actual Python connecting to Snowflake. So I'm going to switch screens here real quick, and I'm going to go over to our Python, our Jupyter Notebook rather. So let me jump into that. Which one is it? So this is going to be our Jupyter Lab. Let me know when you guys can see it. All right, and you'll forgive all my tabs at the top. And so right now you should just be able to see the Jupyter Lab browser window. All right, so if we're good there and nobody sees anything different, then I'll just keep continuing on, all right? So one of the first things we want to do with Python, okay, well, let me set the stage real quick. So what we are looking at is a deployment of Jupyter Lab. Again, you can call it Jupyter Notebook if you want. And I've already explained kind of, what that is in the background of that a little bit. And it's running in my local environment. So this is literally running off my laptop. And I've got a MacBook Pro. It's a pretty decent one, right? It's a couple of years old, but it's got some good RAM here. And so what happens in Jupyter Lab, Jupyter Notebook, is you have these cells, and each cell can operate independently, which is really great because if you think about like a waterfall programming language, like typically if you press like compile and run, it wants to run everything all at the same time, compile everything and run everything at the same time. But in Jupyter Lab, you can actually run sections at a time. So I can write like one block of code. I can run that, and then any variables that were set in kind of the upper level cells will be available to the cells that are lower from whatever was above it if I run that cell above it. And then I have the option to kind of skip around in the cells. If I want, I can run the first one and the third one and the seventh one. But typically people run them one after another after another. Okay, I might be telling people, a lot of people what they already know. But again, just giving a little bit of background here, because for some people it might be their first time. So if I run this first cell, you can see it's doing something very similar to what a lot of different languages does. It just imports a bunch of libraries. I'm going to use those libraries. You can see here we've got Snowflake connector, we've got pandas, which we're going to use for our pandas data frames, calendar. We've got some import tools here from Snowflake. So this is a very, very basic, 10, 12 line configuration just to import the basics, okay? So what I'm going to do is I'm going to go over here to the edit. I'm going to go clear all outputs. So that means if I run this before at any point in time, and you'll see here in a minute, it just cleans it up. It just cleans up my notebook here. So the next thing I'm going to do is I'm going to click on the play button, and you can see here it says run the selected cell and then advance to the next cell. So I want to run this because I want to set up my imports correctly. So I need my imports because otherwise, if I call another library, or if I call another cell rather, nothing's going to happen. So I called the first one, and you can kind of see that there's a number that's been placed in here. So it's like the sequential run. I was doing some testing before this meetup to make sure everything worked properly. So right now I'm on like the 107th cell run of the day, I think, right? So nothing spectacular. So now the next step, the next cell, and you can almost think of it as a step, is I'm going to set my connection. Now I'm a big fan of documenting code, which if you guys write any code, or if you do anything where you have to write logic, I highly recommend, of course, everybody document their code. So please document your code when you can. So this first step here is it's basically creating a connection using the Snowflake library to our instance. And I'm going to have to type in my password here in a minute. This is our account. And this is our warehouse we're going to use for Data Lakehouse. And this is the database that, if you saw our last meetup, we did a bunch of COVID data analysis using Snowflake. So that's just kind of left over from that. And then we're calling the schema. So we're basically setting in Snowflake what they call the context. And that's super important, especially if you've used Snowflake before, you know how important that is. So if I press the play button or run button here, it's actually going to try to go out to Snowflake and connect. And you see how fast that returns. So, I mean, it's always great when something's very responsive, right? Especially in technology. And you can see down here, it basically gives me a bunch of errors, and ultimately it says it failed to connect, password and everything was not correct. So what I'm going to do real quick is I'm going to pause my screen so nobody gets to see my password, and then I'm going to jump right back into it. So let me see here. Pause, and then no one should be able to see me type in this password. All right. Now, chances are in this meeting, I'll probably happen to scroll up and the password will still be there, which I think has happened to me before, but we delete these users right afterwards anyway, so it won't be around for long anyway. So then the next thing that we'll do is we'll go to the next cell. So what we want to do is just like super simple. We're going to go ahead and get the, we're going to run the cursor and then connect. So let me pause here for a second. All right. So in the cell above, when I create the connection, we basically create a variable called a connection. And that connection variable, I think we called it like CXN connection. And then there is something called a cursor. So a cursor is a pretty common thing. I actually I pulled up something on Wikipedia. I'll show you in a minute here on like what a cursor actually is, what it actually means. Because sometimes you'll see examples, even like on Snowflake documents or on Stack Overflow, and people just kind of throw out the example, and then all of a sudden you're copying and pasting, and then somebody asks you, well, what's a cursor? What does that mean? And you're kind of like, I don't know, it just works. So I always find it helpful to actually find out definitions of what you're actually using. So that way you can talk intelligently about it in case somebody pings you about it. So But a cursor is a programmatic connection term, and I've got the link to Wikipedia for you in case you're curious right here. All right, so I made the connection, and then each connection, pretty much in all languages, really have a cursor, especially in Python. I'm almost 100% on that. And that cursor basically says, hey, once you're in that connection, you can loop through a record set, you could loop through the metadata. So it's like a point and reference in that data, okay, for whatever's being returned by your client library. So in this one, we're going to take that cursor, which is basically a pointer to the connection, and then we're going to execute something using that cursor, which is a pointer to the connection. So that way I don't have to like reconnect every single time I want to run something. So here I've got a simple current version. For those who use Snowflake, I don't know if you knew that Snowflake has versions just like every other software. So I'm going to click play on this, and all right, so boom, I've got a little bit of data right here, because we're not building a web app here, right? We're just trying to use our programming language of Python to retrieve data points, metadata, and then use that data, those data points and that metadata in our code to do whatever we want to make sense of whatever's being returned. So again, we're not seeing big fancy graphs and charts yet. So that's we're on version 5.19.2, and I would assume that anybody that ran this in their environment today, Snowflake, would get the same version number. Okay. So then our next one that we're going to run is just a retrieval. So what have we done? We've connected, we've got the cursor, and we did just a general select against the version. It's like metadata of database. And so on this next one, we're just going to retrieve some data from the COVID data set. So let's go ahead and run that and then talk about what we're getting. So look at this data set, and that was fast, right? I don't even think that's probably cached since I ran it a couple times, but not bad. So we're pulling this one out of the COVID-19 data set. And what's the query, right? Select all these columns from the World Health Organization's daily report. So on a daily basis, World Health Organization reports, we capture just that daily stats in one table. So there's only like one record for every country, so like 200 plus records. And so what we're going to do here is we're going to loop through that cursor, using a cursor. We're going to loop through the data that's returned. So for every record in that cursor, we're going to basically use some print formatting syntax. And if you're familiar with Java or I think C++, like your print F or print S, if I recall correctly, it's been a while since I worked with C++ or C. You get kind of like a formatted output of whatever argument you pass into it. So here we've got 3 columns we're returning, 1, 2, and 3. And then we're just printing those out, and it's looping through the print. So we're going to get 1 row, each 3 columns printed out for every record that's returned. And that's exactly what you see. Nothing fancy at all. And, I think for cases for the US, I think that's actually coming down since our last meetup. I don't know. I'd have to have a fact check on that. So we could clean this up. This is a huge list. It's going to detract from what I'm looking to do. So I can simply right click on this and I can say clear outputs. Now I'll just clear this output for the cell, as you see. And now it looks like technically I didn't run anything, right? So it's a way to clean up as you're going. And again, on each one of these, like this is super basic, right? But on each one of these, the concept is as I'm pulling data, like I'm writing like a significant amount more code here, right? Like I'm joining it. I'm putting some sort of conditions or rules to it. But we're just walking through the basics, right? So now this one's a little bit different. For those who know Python and have done some data science, what I'm gonna do is I'm gonna take that same query and I'm gonna run it into a data frame, okay? So here, if I run this, I'm actually setting the variable before the try, and I'm setting an option here for max columns. We'll see what happens. And then I'm using this fetch pandas all, which I think actually comes from, it comes from Snowflake. And it's kind of just a quicker retrieve to pull everything in without having to identify any of the columns and so forth, and map that into the data frame. It does it kind of automatically. So if I run this one, you'll see that I get kind of a nicer printed, formatted table. And what's really cool, so this is basically a data frame output. So I ran an extra command down here at the bottom called df.head. And if anybody's familiar with Linux, it's kind of very similar thing. So if you're doing like, for like a file, or if you're doing like a tail and you do like head, you're just getting kind of the top X rows, based on your numerical argument, right? And that's coming through. So let me see. I think I heard someone had a question. Yeah, Andres, let me see here. Let me see. I don't know if I can unmute you. Let me see.
Can you hear me?
Yeah, there you go.
Hey, hi there.
How are you?
I'm good, and you? Hey, just
good, pretty.
A quick question here. So when you load you use this method, are you loading data into your RAM memory?
Yeah. As far as I know, and I've never contributed to the Pandas data frame open source library, but yeah, pretty much everything is pointed to memory at this point, as far as I know.
Do you know any option? Let's say that I have a 10 gigabyte data frame that I want to put out of Snowflake into Pandas. So that's going to kill my computer. Do you know if there's anything more advanced coming from Snowflake to avoid going like first downloading the data into your RAM memory and second using your RAM memory to process with Pandas?
Yeah, so that brings up a couple of points and maybe something for another meetup for sure. So I can probably think about 3 ways to respond to that question, right? So I don't know if you caught the beginning of the meetup, but we were talking about Jupyter Hub versus Jupyter Lab on the laptop. And so what we do as part of the data lakehouse and for some other folks and ourselves as well, we stand up a Jupyter Hub instance, like on either Google Cloud Platform or like AWS as a virtual machine. And so we've got, clients and customers that are pulling in, 5, 10, 12 gigs of data into data frames, parsing, manipulating, because we can scale out that server and that memory for those particular loads. Like, I'll give you an example. Like, one of our customers was running a really cool Python process, and it actually like stepped through movements of a transportation process every day and did like, and it, on the guy's laptop, it was taking like 30 hours. Like, he would just set it there on Friday night, you run it, you check it like Saturday and Sunday, and Saturday it'd still be running. And then we stood up Jupyter Hub, put up a machine that I think it had like 64 gig RAM and I don't know, like 12 virtual CPU. And the same thing finished in like 2 hours, right? So we took you take a sample of the data, run on your laptop, make sure whatever process works, and then take that same Python notebook, stick it up in on Jupyter Hub in like high capacity. So that's one way you could do it. Another way you could do it, even though we're not talking Python per se, is in theory you could use PySpark, but you could use Spark in general. And there's a lot of discussion about using Spark because a lot of times when people use Python or they're pulling data from Snowflake and they've got lots of data, one of the problems that slows things down is not so much the memory, it's the operations they're doing in memory. And so using like Spark as that load and transformation engine could reduce the load that you're taking on in the way you structured your Python transformation, if you will. So that's one way. And then you get the combination of like things like better in memory movement of data and transformation, and then just the use of memory in general.
Okay, thank you.
I think, yep. And I think I said one more way, but
Airflow maybe.
Well, yeah, I mean, Airflow. I mean, in theory, also, I mean, if you have 10 gigs free on your machine, right, you could always download that into your machine, right? Like, you could just download the 10 gigabytes of data in your machine, and then in theory, you could chunk that, through whatever process, like take the first 1 gigabyte and run that through whatever you're doing in Python, whether it be data frame or not, and then push that, up to a stage or back into Snowflake, right? Almost like chunking it along. I mean, that'd be another way to do it if you're like completely resource constrained. I've seen that before too. So,
thanks.
But you shouldn't have to get that creative, right? That's a great question. I hope somebody corrects me on the memory thing. Again, I'm not 100% everything's a memory, but I'm pretty close to it. All right. And data frames is amazing, right? It's quick, it's fast, and it can do a lot of great things. So the next one here, just kind of stepping forward a little bit, is calling standard, I guess you can call these like DDL, DML, admin type functions, right? Because if you are really trying to use Python to interact with Snowflake, you might want to do more than just reading data and transforming the data and turning it into a CSV or pushing it somewhere. So as an admin, you might want to automate a process or automate like provisioning roles to new users or writing a script. So you can absolutely do that in Python. And so just to give a little taste of that, what I'm going to do, if you remember before, I was using this database here that has the public World Health Organization data. So I now want to switch that because I can't write to that data set. If you remember from our previous meetup, that's a shared data set. So I can't write into that. So what I have to do is I'm going to switch to another database by using the use database called DemoDB, which is a database we already have created. We're not worried about that. But in that database, I'm going to create a new schema called MeetupDB with the date of today. And then I'm going to use that schema to do any further operations. And then what I like to do sometimes, just like in programming, I like to kind of have like just an indicator that tells me if like something failed in this process. Did I get to this point, which is not really a big computation or data call. So if I run this, my only output should be the version of Snowflake, if it works. Otherwise, it'll fail. Okay. So just by going, because everything's kind of waterfalled like most languages. So it's gonna run this one, it's gonna run this one, and if they all succeed, then it should reach this one with no problem. And it did, because it output the version number. So we're good there. So this is basically like just context setting. Like there's nothing major here. It's just kind of setting some things, creating an object in the back end that's structural to my database. All right, and then we just have a couple more here to go, and then we can really kind of open it up. So the next one is, now that I've got the schema, I'm using the schema, because remember with Snowflake, you have to tell it for just about most of the interaction, what's your role, what's your warehouse that you're going to use for the compute, what's your database you're using, and what's your schema. All right, so those 4 things. So now what I want to do is, now I'm using that schema, I want to create a new table. And it's going to be called Meetup Guest. And if it's already created, it's going to replace it. And then once it's created, it's going to go ahead and insert a couple records. And I've got my first record here, which is a guest to Elon Musk. 888 Sky High is his phone number, and he's interested in rockets, cars, space, crypto, and datalakehouse.io. So I'm going to run this, and then it's going to give me the current version, like before, and then it's going to go ahead and give me a list of the guests. So let's go and run that. All right, so here we go. So, the one thing I forgot that I was doing was I'm actually printing out here the cursor query identifier. So one really cool thing about Snowflake, again, which I'm not sure everybody knows, but you'll learn right now, is every query that you pass into Snowflake generates an identifier for that query and pretty much captures that query information. And so it's like a great way to track anything with that query, its performance, its load time, its pull time, its read time, whatever it might be. And yeah, we'll probably have another meetup on looking at some of the query profiling information, but for the most part. And then you can take this identifier and run it through query profile or find the query and its specifics. And so that's a really good one to know. So we can just print that out with the cursor. It's part of the metadata. So as soon as you run that cursor, run any command against Snowflake, because every command is basically SQL, you can get that query identifier by running cursor.sfqid. And then of course I'm using pandas again here, but you'll notice I'm doing just something different with the pandas. I'm not actually printing out the data frame, I'm printing out an instance of the data frame, which is basically turning it all into like a string and just taking part of the data frame logic. I wanted to show that because it's a little different take on using the actual data frame for what it is in Notebook. And here we can see the printed out user. All right, so I think the last one, yes, is going to be inserting records. So what's interesting about the Snowflake client on Python is in my opinion, there's a few bugs in some of it. So, testing using the community forums and Snowflake, Stack Overflow is going to be your friend. I mean, you can do quite a bit, but not all of the documentation for Snowflake works as intended, I think. And that might be a bad call. Maybe I just don't know what I'm doing, doubtful. But and so it could be something with like the versions of Python you're using, the things that you're importing, how you're using it in your code. If you're using, like a try block and accept, this type of thing. So your mileage may vary. And again, setting up your environment's very important. And that's why I'm a big fan of standardizing on environments. So definitely, read any documentation you can from Snowflake. And then of course you have to find out how you take that documentation and kind of match it to whatever environment of Python or version of Python you might be using, depending on the flavor and the setup you're using. And if you're using like virtual environments of Python and all those sorts of things you have to consider. But so with that being said, let's look at this last one. We're still setting our cursor. We're going to use a try block. And then we're going to just insert a couple more records. So we're going to insert Albert E and Nikolai T, and we're going to try to add them to our new table meetup guests. So I'm just going to run this. Okay, and then I went ahead and printed out the standard format data frame again here. And then I also pulled out the identifier, which of course is different than the one above. So now I've got all three guests in my system. So we just walked through, how to connect, how to read the cursors, how to loop through the cursors, how to select general data, how to insert data, a little bit how to use data frame. I mean, that's like the absolute 1% bare minimum of using data frames with pandas. This is not an ML or data science meetup, but maybe we'll have one soon. And anyone here who's on the call is super welcome to contribute to the meetups or presenting, as well as providing ideas. We always look for ideas, right? So if you have any input, definitely interject that in our forum. So we're going to do a couple other ones, and then I think I'll wrap up with just what I did mention is at the very bottom of your code, you typically close out your connection. Because if you think about your connection to Snowflake, it's almost like you're logging into the user interface, right? You go to the browser, you type in your account in the URL, and then when you log in, you've created a session, right? And that session is open as long as your browser is open. And even if you close your browser, you log back in, or you open your browser up again, typically you're still signed in because your session's there. Same thing with connecting through Python or another client. So a best practice is at the end of your code, or when you finalize all your code and your logic, to go ahead and close out that connection. You can even put some logic or like a try catch block around it. A simple if connection exists, then close it will work. And then if I run this, right, gets me to the next one. If I run it again, it still works because connection is basically like a nullable. But if I go back up here, technically, and try to run this, in theory, it shouldn't run. Yeah, so I instantly get an error. You guys saw that working. Connection's closed. So my session's out, my connection's out, and then I can feel comfortable. I can walk away, and I don't have any open sessions of my code or anything like that. All right. So let me jump back over to a couple other slides, and then we'll just wrap up. See if there's any questions as well. So let me make sure I'm presenting this other slide. And I think that is presenting, so I'll share it out. And then you guys tell me if it seems to be working.
It's up.
All right. Actually, for some reason, I can't see it, so that's not good. All right. All right, let's try that again. Presenter mode. All right, and then share that out. Okay, so last couple of slides here. I mentioned to you guys that we had a few things in the demo we wanted to cover. I think we hit them all. Credentials, and we could talk about different authorization. There's SSO, there's OAuth, there's SSH keys, that type of thing, or private key kind of login. So we did all this, and lots of lessons learned, I think, out of that, especially if you're new to Snowflake or you're new to Python. We talked about cursors and data frames, Jupyter Notebooks, Jupyter Hub, a little bit about restricting access, definitely Python. And the one we didn't cover today, because it's probably a lot to take in if you've never done the integration in Python, one which is pretty fun, it's called Asynchronous Queries. And just to talk about that for a couple of seconds, it's generally, think about it, right? Somebody mentioned having a 10 gigabyte set of data, a data set. So let's imagine you had that in chunks, right? And you want to do an operation on that. So an asynchronous query, you could kick one off, you could kick the query off one at a time, and it's going to run asynchronously, right? So you could come out, and then you could wait, you could run the query ID to kind of see, what's happened to that execution that you ran. So it won't be linear, if that makes sense. So it's kind of a non-blocking sort of query. So to let you kick it off, you can do things in between. You can wait for it to return, or you could go do something else and then ping it to see if it returned or finished or completed the execution, and then continue on to do something. So it's a little different than what we went over today, which is pretty much just calling something, waiting for it, nothing else was happening. We couldn't do anything else until that query completed. And then once it completed, we could do something. So one's synchronous, one's asynchronous. Yep. And then we'll leave you with this definition of what a cursor is in a database system. So I think, yeah, guys, let's open it up for some Q&A, and definitely make sure that you tell a colleague about joining one of the upcoming events. And we've got a few lined up, and we're adding more to the schedule this week. So it's fun for us, and we hope it's fun for you guys too. Okay, let's see if there's any questions. Okay, I had a few people jump in as we were going there. So let's see here. So I'm sure somebody's going to say they knew all of that already. If that's the case for anybody, love to hear your take, or how you've been using Python with Snowflake. If anybody wants to share.
I would like to share. I work with Snowflake a lot, so we have developed. So far, we have not used Python yet. We are still working with challenges about the memory and the cost of downloading the data, but we have used different stuff to build, like mainly Informatica for data ingestion, and for ETL Airflow, and even ThoughtSpot. I'm not sure if you have heard about it.
Yeah.
So So Databricks as well, to connect and process the data, and then moving the data to Domino for processing. So that's the cloud that we are currently using for analytics and data science and stuff. And well, mainly SQL. So I have a question for you. Could be probably a little bit out of this discussion, but have you built applications yet?
From or with Python?
with web front end, with web front end in a web browser, and then you call the data, and then you expose like a dashboard?
Yeah, absolutely. We do it with our platform, Data Lakehouse, and and we've done it for some other folks as well. Yes, I mean, it works pretty well. I mean, if you're talking about directly against Snowflake, yes, and
React or Angular.
We're more of an Angular fan shop on the team I'm on my team, but we do also do some React, but not as much as Angular. We're bigger fans of Angular for some reason. We're gluttons for punishment over here, I think. But
nice. Can you share me your information? So we
can.
So I can check your webpage if you have some, or.
Yeah, sure. Yeah, we can share. Yeah, it'd be interesting to know what you got. You guys have a lot of tool sets there. Domino, ThoughtSpot. What else did you say?
All of them.
Right. Oh. Yeah. Well, I'll tell you, we talked with the one of my old colleagues is a IT director at a large retailer, and they actually switched a while back. They had Informatica and SSIS and some of these other tools, and they actually switched to like a pure custom-built Python process for both loading all their data into Snowflake and then any operations to pull data down. Not to say there's anything wrong with Informatica or SSIS. I'm a big fan of both because they have great tools. But sometimes it's like if you're going to a new like initiative, maybe with Snowflake, sometimes it's easier just to say like, how fast can we go? And if something works like in Python and you can scale it and you can keep it stable, then that's nothing wrong with that.
In my experience, we are using IICS because to move really big chunks of data, that's the only tool that is reliable to move the data. Like if you want to ingest 20 gigabytes every day, that's the only tool that's really reliable. And even well, in my opinion or in my experience, like even Databricks is not that reliable. And the other thing that IICS has that is really cool is listeners. So if you want to have a real-time ingestion and you use listeners, it's all the job is done with that, and very simple with the cloud with Informatica Cloud Service. So
yeah, I'm familiar.
I just drop you here my information so we can connect if you want.
Okay.
Cool.
Yeah, I have a question about the ICS and Snowflake. So for the streaming data, can you guys use that ICS, or it's only for that if you load some real-time data and all those things?
I am using for real time. So I have I have many different streams or different business cases that I'm using Informatica, and I'm using listeners, as I mentioned. So for example, I just set up a project where I have some FTP. So we are receiving data out of the corporation. And then of course, the data is going through all the security. But once I receive the data, I just ingest the data, or I just set up a listener on the location on the HFTP. And then the data just flows through automatically to Informatica, like real time. So that's one of the business case. Another one could be like sensors. Like I used before Databricks, or tried to use before Databricks, but Databricks is not, once again, that's my opinion, but Databricks cannot be really reliable. And Informatica for me has been the only tool, and it's not the best. It's not the most friendly tool. It's not at all, but it's the only one that has brought us reliability on ingesting really big data continuously. If that helps.
So we are kind of exploring the Azure Data Factory or some other tools. We are also exploring Databricks to do the so we have to migrate some like on-prem data to Snowflake. We don't have the ICS and all those, so we are kind of exploring either with the Python, or second like Azure Data Factory. So this still we are trying to assess, and third one we are thinking about the Databricks.
ADF is a really good tool. It pretty much depends on your needs, and of course it's not my company. I work for a company, so we have the budget to have all the tools because we have. We are ingesting source systems, so we have we ingest probably more than 100 gigabytes every day just from source systems. So we really need to have a reliable tool to complete this type of jobs. But if you don't have the needs to ingest at a specific point of time, like you just have 1 hour to do the full ingestion and that stuff, you can just explore like ADF. I think ADF is a really good tool.
Okay, so there is no data size limitations, right, in the ADF and all those?
No, but there are some. There are no limitations, but there are no such flexibility.
Mm-hmm. So you are going with the ICS and all those as one of the.
Totally. And I tell you, I don't like IICS, but it's the only tool that has really solved all our issues, including the sensor data, like ingesting sensor data. which is really complex. And it gets complex really easy, especially when you don't have a timestamp. Informatica has some tricks to add timestamp on real time, and then that really helps you a lot to solve your problems.
Interesting. So other topic that suppose that if you're doing in Python and we have to convert, like if we have like BT script and all those and on-prem, we have around like 1500 script. So is there something in Snowflake? I heard about the Snow Convert and all those. We can do the conversion of those Teradata BT script into kind of Python environment and Snowflake. Have you guys ever used it? Like
I don't know if we've used Snow Convert directly, but we have done stuff. If you're asking me, that is, I mean, we have done some stuff with stored procedures. So there's a lot of folks who are trying to like completely migrate into Snowflake for their data warehouse, and a lot of data warehouse developers, architects, eventually just wound up writing a bunch of SQL code. So they might have been using SSIS or Informatica, and then they wound up just writing a bunch of SQL and then pulling that in from a stored procedure because they thought it was easier. And so now there's a lot of Snowflake customers that are trying to migrate. And so they're trying to take all those stored procedures and put them into Snowflake, and either still use them as stored procedures because there's like arguments and they're parameterized and they're doing kind of like variable setting and things like that. So we actually created a set of scripts that helps kind of accelerate that process. But I haven't really seen anything for converting like VB into Python for Snowflake in particular. Is that what you guys have, Ravi? Or are you saying you have?
No, so
VB
we were
scripts
talking
for
to the
Python?
Snowflake guys. They said they recommend that Snow Convert, which basically takes the code, on-prem code, and converts into the like Snowflake kind of thing, and which can be run in Python. So that's what we have been told. So we have like around 2000 script, and we don't want to rewrite everything and all those, right? So it's going to take very, very long time and a lot of resources and all those. So we are looking for something which can do things quickly, like in 2 weeks, and we can kind of set that up in the Python environment.
Yeah, that's one to take a look at. I mean, we've built a lot of tools to kind of help accelerate, because like, even if it gets you 60-70% of the way there, like the automation saves you so much time and so much headache, right? Like you were saying. So, but that's an interesting one. I'll have to look that one up. Why are you guys moving away from batch scripts? Batch scripts are awesome.
So we are moving to like on-prem to cloud. So on-prem we have all the batch scripts, and but now we are going with the Azure and Snowflake, means ADLS and the Snowflake. So we have to migrate all the on-prem data to Snowflake.
Right.
And we have kind of big data warehouse, so we have to convert everything into the Snowflake thing.
Got it. Yeah. And so the idea being that the cloud operates more universally with maybe Python, versus VB script or, shells, maybe not shell scripting, but batch script rather.
Yeah.
Okay. No, that makes sense. I'll dig into that a little bit. Okay.
Yeah, but thanks for all the info about the ICS and all those. So ICS, we haven't planned to spend money on that yet, but we are still kind of in the assessment phase.
Awesome. Well, I think that's a time. Before we wrap up, I mean, maybe we could, if anybody else has anything else. We also have on the meetup, as you guys have probably seen, there's a little bit of a form for communication there to kind of ask around questions or submit topics for the next event. Our next event, I think, is on June 21st, which kind of goes into a little bit of the discussion here, especially when you start talking about ICS and Andreas and things, because if you have stages, especially with like IoT or sensor data, the stages allow you to do this great, kind of real time, object storage dumping of the data, and then having Snowflake's massive scale-up capability to kind of read that information in just about near real time and ingest that, X number of gigabytes at a time. So definitely one worth attending, and we can talk about some of those advanced topics during that one too. So that one's June 21st, 6 p.m. So if you guys have any topics you want to see covered during that meetup, around anything we're talking about here, we could probably get some stuff thrown in there. So, all right. So I guess we'll go ahead and wrap up there. Everybody, appreciate your time, and thank you so much for participating and the good conversation.
Thank you.
All right. Thanks, everyone. We'll see you on the next one. All right. Have a good night.